of the Department of Defense. I had an idea 2007 and 2008 that nutritional ketosis could be a strategy for mitigating what's called oxygen toxicity seizures. That's primarily concerned with special operations warfighters using a particular type of breathing apparatus. And I'm in a pharmacology department and a physiology department, and when I started becoming interested in the ketogenic diet, there was some resistance against that maybe, and I mean, one comment was it's academic suicide, to study a high-fat diet and the science, for something I was really focusing on drug therapy for. But the Office of Navy Research took a risk, and they supported the development and the testing of exogenous ketones. And that's what I'm going to talk a little bit about the history and a little bit about how our research program evolved to ultimately develop the product that you guys are taking today. I think I got it backwards. Okay. So my background as a PhD student, I studied hypoxia and specifically the neural control of autonomic regulation. So our brainstem controls our heart rate and controls how we breathe. So luckily we don't have to think about breathing. It's an automatic response, right? So my research really delved into the brainstem mechanisms that sense oxygen and CO2 and modulate our respiratory output. And I looked at a particular area of the brain called the pre-Botzinger complex, and it was an oxygen sensing region that controlled sort of the pacemaker-like activity of autonomic regulation. But really it was sort of the work that I was doing was primarily involved in understanding how the body responds to low oxygen and modulates physiological output to control our physiology. So that was during my PhD studies, and during my postdoctoral fellowship, I went on to the other end of the spectrum. Instead of looking at low oxygen, the extreme of low oxygen, looking at the extreme of high pressure oxygen. As I mentioned, the Office of Navy Research, one of their research programs is understanding the cellular and molecular mechanisms of CNS oxygen toxicity seizures, which occur using a closed-circuit rebreathing apparatus. So understanding, another interest that we have in the lab, and I have personally, is understanding nature's sort of keto adaptations to extreme environments. And I think we have a lot to learn by doing what's called comparative physiology and understanding how animals adapt to the wild when they're faced with starvation, or when they dive to extreme degrees of pressure and lack of oxygen. So some of the research that I've been involved in, and my fiance, soon-to-be wife, next week we get married. Thank you. Something that we do, we travel all around and we study manta rays. So manta rays have the largest brains of all fish. They're like the Einstein of fish, really. And what's interesting is when you compare manta rays, which have this enormous brain, if you plot brain size versus body size on a plot, like manta rays are literally off the chart. So they just have these enormous brains, and we're trying to figure out why and what they do with all these neurons and astrocytes. So the brains are fueled off ketones. So if you measure their blood ketones, which is something that we do when we've traveled, unfortunately these are protected animals. But the Chinese fishing market is actually the gill rakers are very valuable, and they are killed illegally. And we've visited various fishing camps and have been able to collect brains and look at the blood and do some metabolomics on the blood. And what's interesting about these animals is they'll dive down to 2,000 feet, and they'll do that like 8 to 9 times per day. And other fish really don't do that. So I was really interested in understanding how they adapt to this low oxygen environment. And their brains are fueled off ketones. really. And if you want to know more about this, as we've collected tissues and we're looking more into their ketone transporters and the lactate transporters and the various metabolomics associated with this. There was a TED Talk by Dr. Chilla Ari, my fiance, gave a great TED Talk on their learning abilities. So the Office of Navy Research also in the past, they funded a lot of this comparative physiology work. So we're looking into starting up another program on that and to further understand how these deep diving animals utilize ketones as an energy source. So getting back to CNS oxygen toxicity seizures, it's a limitation for hyperbaric oxygen therapy, which is used for 14, I think 15 different FDA-approved applications now, including decompression sickness, which if you're a recreational diver, you know about that, the formation of nitrogen bubbles, carbon monoxide poisoning, ischemic wounds, crush injuries. There's a lot of applications to hyperbaric oxygen therapy. A limitation of that therapy is oxygen toxicity seizure. So if we could mitigate that, and actually allow us to give a higher dose of oxygen, we could get a better therapeutic response. Like if someone has carbon monoxide poisoning, the high oxygen pushes the carbon monoxide off the hemoglobin molecule. And we could do that twice as faster if we could increase the pressure, but they'd have a seizure. So we're looking at ways to enhance that therapy. So it's also a limitation of, as I mentioned, special operations diving. And just to give some context, at just 50 feet of seawater, the potential for having an oxygen toxicity seizure can occur within just 10 minutes. So, and that's not very deep, right? So 50 feet of seawater is within visibility. If you're in a helicopter looking down, you can identify people. And I've talked to a number of divers, and they go much deeper than this, and many of them have been hit with oxygen toxicity. Now, rebreathers are becoming very popular in recreational diving. So I've connected with the recreational dive community that's using these oxygen rebreathers, and like any sport, right, they're all pushing the limits. So the problem is that you're going to see a lot more deaths and fatalities associated with oxygen toxicity seizures. So here's an example of a seizure, if we could play the video here, that's triggered by oxygen toxicity. You guys see that?
Oh yeah, get him on. Yeah, pull us on. Here, lay down. Lay down. Lay down. That's it. You're just fine. You're just fine. Lay down. You're fine. You're fine. You're fine.
So I don't know if you could actually see that, but oxygen toxicity seizures are very powerful, what we call tonic-clonic seizures. And I showed that video at another conference, and they just said it was like too much to freak people out. But hopefully you guys didn't get freaked out. But they're very powerful tonic-clonic seizures. And that was done in, he wasn't underwater, but he was in to give kind of an example of why the other guy didn't have a seizure. He was in a hyperbaric chamber pressurized at 2.7 atmospheres, and he was breathing pure oxygen, but the guy next to him was just breathing hyperbaric air. So that's why he didn't have a problem. But when he had a seizure, he took the mask off and was breathing air, and that stops the seizure within about 30 seconds. So having a seizure isn't in and of itself something that could kill you. It doesn't do your brain any good, but it won't kill you. But having a seizure underwater obviously could be, it will be fatal to the mission and fatal to the warfighter. So we want to understand why these seizures occur and how we can prevent them. So we've developed, before I got into developing ketone technologies, almost all my time and effort was spent developing various technologies that could allow us to study the physiology and the cell biochemistry and the cell mechanics under hyperbaric pressures. So we developed some unique technologies, including atomic force microscopy and fluorescence confocal microscopy at hyperbaric pressure. So what these chambers allow us to do is to look inside cells and even optically section cells and look at the cellular response to graded levels of oxygen. So we can look at cellular excitability, we can look at free radical production, or what we call reactive oxygen species production as a function of oxygen over time. And that will give us kind of a snapshot of what's going on in the brain. On the other end of the spectrum, this chamber, actually we look at cells and tissues, and we also have chambers where we can do whole animal studies. And in our whole animal studies, we can monitor a variety of physiological parameters, including heart rate, diaphragmatic EMG, so we get respiration, and EEG, body temperature, activity, those sorts of things, inside the hyperbaric chamber, so we can simulate these physiological conditions. And then we take the pressure to where it causes the seizure. So these technologies allow us to test ketones and basically screen out the various types of exogenous ketones that have the greatest therapeutic effects. So I'm not going to show you all the science and get into the cellular mechanisms in this talk, but I'll just convey the message that high oxygen pressure, what we've discovered is that high oxygen pressure ultimately leads to a metabolic dysregulation, mitochondrial dysfunction, impaired glucose transport and utilization in the brain. And why that's occurring is something that we're studying, more intensely now. And it also contributes to oxidative stress. And we think that maybe the high levels of free radicals can further impair metabolic function, mitochondrial function, and that ultimately causes neuronal hyperexcitability. The brain becomes very hyperexcitable. And we have various tools to look at the mechanisms behind that, and this triggers a seizure. And it's rapidly reversible. So once the oxygen level, breathing level comes down, the seizure can quickly stop. So it's a transient sort of event. So some of the strategies that have been tested to prevent these oxygen toxicity seizures, the military has been looking at this for about 35 to 40 years now. And some of it's published, much of it isn't published. But what I've discovered is that antioxidants are largely ineffective at preventing these oxygen toxicity seizures. Ketones are kind of an antioxidant. They lower reactive oxygen species. They help activate endogenous antioxidant pathways. But antioxidants work really well in cell cultures and what we call an in vitro preparation, but they tend to fail in animal models and in humans who have tried them. Anti-epileptic drugs are largely ineffective at preventing these oxygen toxicity seizures. I'll say the dosages needed to prevent oxygen toxicity seizures are very high, and it would put a warfighter into a sedated state. So it's not a good idea to load up a warfighter with anti-epileptic drugs that have a lot of side effects that would dramatically decrease their cognitive function and physical performance. So a few papers that stood out to me when I was really delving into what could prevent these oxygen toxicity seizures is the data supporting the idea that starvation ketosis or fasting ketosis can delay the onset of oxygen toxicity seizures by up to 200% protection. And that was about better than any anti-epileptic drug out there. And so I became really interested in this idea. I knew a couple people that were in the special ops, and they were doing some intermittent fasting. And at the time, about 6-7 years ago, that was kind of a new idea. So I became, further engrossed and even, just fascinated with this idea of how does fasting change brain energy metabolism. And we have reports going back to centuries, in scripture even, and in the time of Hippocrates, showing that fasting can cure seizures. And it's an early report here from, I think, 1922, fasting as a cure for epilepsy. George Cahill from Harvard Medical School, I had the opportunity, was fortunate enough to connect with him early on, and I would call him on the phone and we'd talk about various things that he did. And he was really the thought leader in understanding the metabolic physiology of fasting, and more importantly, from my perspective as a neuroscientist, how brain energy metabolism changes in a fasted state. So fuel metabolism during fasting ketosis is really, it's a normal metabolic state. And ketosis is highly influenced by food availability. So it's really easy for us in our modern society to eat 3 or 4 meals of high carbohydrate. That's standard. That's what the standard American diet consists of. So going in and out of ketosis was really a normal state, that we evolved to, and that's largely silenced really by modern life and modern food choices. So, and Jacob gave a great overview of what ketones are, and I love the analogy of that they're water-soluble fat molecules. So by enhancing fat oxidation in the liver, you create these ketone molecules, and they can readily cross membranes more efficiently than fatty acids, especially for the brain, and they can preserve brain energy metabolism during periods of limited glucose availability. So I get this question a lot. Are ketones the preferred substrate for the brain? I think the brain will use basically whatever is available to it. And we know that the transporters and the ketolytic enzymes that are responsible for making ketones, converting ketones into energy are in our system no matter what. We don't have to follow a ketogenic diet. And this was a little bit confusing to me when I first started doing this research, because I was reading all the ketogenic diet literature, and then I discovered, the NIH in Oxford were doing some research on a ketone ester. And I was like, well, I thought your body had to adapt to nutritional ketosis before your body could effectively utilize ketones as fuel. But that's not the case. So our physiologies are more or less hardwired to use ketones as an energy source at any given time. So that changed my idea on the idea of using, on the strategy of using ketones for what I wanted to use it for preventing oxygen toxicity. So what Cahill and colleagues, Oliver Owen, showed in 1967, I think prior to 1967, our understanding was that the brain could really use only glucose as an energy source. And he did an elegant study showing that in a fed state, our brain does use about 100% of our brain energy is derived from glucose. And in a state of starvation, or what would be maybe a strict ketogenic diet, the brain can derive up to 2/3, maybe even 70% of its energy supplies from ketones, including beta-hydroxybutyrate and acetoacetate. So this state of that was during starvation ketosis, and we know that fasting was reported as a cure for epilepsy, and there's a lot of benefits to fasting ketosis that we're just becoming aware of now. The anti-inflammatory mechanism is something that we're very interested in understanding, and there was some work done at Yale University that used exogenous ketones, actually. It was a diet that we prepared in the lab and sent up to them, and their work demonstrated that, it was published in Nature Medicine, that beta-hydroxybutyrate was a metabolite that was contributing to the anti-inflammatory effects. And there's a lot of work now looking in the seizure world. I just came from a conference, an epilepsy conference, where they're looking at brain imaging, they're looking at neuroinflammation. And neuroinflammation is a precursor to someone having a seizure. And once you have a seizure, that triggers neuroinflammation, and a seizure will beget a seizure, right? The more seizures we have, the more we're likely to have a seizure. And it's thought that there's various pathologies out there that cause neuroinflammation, and even viruses that can trigger headaches and neuroinflammation, and these cause seizures. So the inflammatory component is something that the neuroscience world has not looked at much, but we're kind of delving into that now. So kind of taking a step back, we know that nutritional ketosis with a diet can mimic fasting ketosis. So the ketogenic diet is a pretty strict diet. The ketogenic diet, as represented here, is more like a modified Atkins diet, about 70%, 75% fat, 20% protein, so you have moderate or adequate amounts of protein. And when you follow this diet, you have accelerated beta oxidation of fatty acids in the liver. And that high level of fat oxidation in the liver, in the context of a low insulin, because protein and carbohydrates can activate insulin, but restricting them to low levels and giving fat pushes insulin down and accelerates fat oxidation in the liver. And that can contribute to the generation of these ketone bodies. And at the same time, in the context of depletion of liver glycogen and low insulin levels, we're also mobilizing fatty acids from our adipose tissue. So as I mentioned, that these ketones are a source of energy for our brains and our heart especially, and now we're starting to understand that other tissues have the ketone transporter, they have the ketolytic enzymes, so skeletal muscle and skin and other organs can effectively use ketones as an energy source. And back in 2008 and 9, there was a couple books that I would recommend reading. I think it's really important to understand what the foundation of, where this foundation of research started at and how it led to this technology. And the first people that I contacted in the ketogenic world, the first guy that I called was actually Dr. John Rowe. And at the time, he was at Barrow Neurological Institute. And he was really one of the thought leaders on the mechanism behind the ketogenic diet. So the book that I read was Epilepsy and the Ketogenic Diet, and it really delved into to the details of not just the ketogenic diet as a diet, but as ketones, as signaling molecules, as ketones, as energy substrates, as molecules that could enhance mitochondrial function. And Dr. Eric Kosoff was someone that I connected with early on when I read his book, The Ketogenic Diet. So Eric is a neurologist at Johns Hopkins, and he worked with John Freeman, who was one of the original thought leaders and spearheaded the whole ketogenic diet program at Johns Hopkins. So I'd highly recommend reading these two books. And those guys, Eric actually put me in touch with Jim Abrams of the Charlie Foundation. And I've given talks on behalf of the Charlie Foundation, and this is an incredible resource for understanding the ketogenic diet. You have videos on here, you have ketogenic diet recipes. On the left, you have Beth Zupackania. She's the lead dietitian for the Charlie Foundation, and I communicate with her frequently. She's really spearheading sort of the use of the ketogenic diet for other things outside of pediatric epilepsy. The Charlie Foundation originally started as a foundation that was focused specifically on pediatric epilepsy, and I'll get into that a little bit more. But now they changed their name actually to the Charlie Foundation for Ketogenic Therapies. And they get about a third of the people that contact them have questions about epilepsy, and now they have more questions about autism, about type 2 diabetes, about cancer, and about many different types of disorders. So the Charlie Foundation is sort of working to evolve their consulting services to take on more of these special scenarios. As the science evolved, they're really understanding that the diet is a powerful metabolic therapy for things other than pediatric epilepsy. So in the center, you have Meryl Streep. So Meryl is a friend of Jim Abrams and has done a lot of fundraisers on behalf of the Charlie Foundation. And Nancy Abrams is on the right, that's Jim's wife, and she has done a great job in promoting the foundation and advancing it. And Meryl did a movie that, one of the first movies that I saw before I even started doing research was First Do No Harm. And I was told that I needed to see this movie. It is a very powerful movie on the ketogenic diet and its potential as a metabolic therapy for pediatric epilepsy. So Charlie was the son of Jim Abrams, and Charlie followed the diet for several years and was able to wean off of the diet and then transition to a fairly normal diet and had never got seizures again. So the ketogenic diet is the only therapy that I know of that when you follow it, it can actually cure epilepsy. And that's really interesting to me, whereas anti-epileptic drugs, when you remove the drug, a lot of times you get a rebound effect and you get more seizures. So this has created a big interest in understanding the mechanism of the ketogenic diet. I've given talks at UCB Pharmaceuticals that they make the drug Keppra, and they specifically had a conference to understand the druggable targets that could be evolved from ketogenic diet research. So you have pharmaceutical companies like Genentech. So Genentech kind of also invited me to give a talk on the mechanism of the ketogenic diet. And there's people within that pharmaceutical company that are doing ketogenic diet research. Although Genentech has really no ketogenic products out there, they realize that this is such a fast-growing area of scientific research that they need to start doing research in this area. One of the executives at Genentech actually has a daughter with Lennox-Gastaut syndrome, and it's a disorder that there's no therapy for, that the ketogenic diet works remarkably well for. So there are a lot of pharmaceutical companies really paying close attention to the research being done on ketosis, especially as it pertains to anti-epileptic therapy. And we know that anti-epileptic drugs are largely ineffective for at least 30% of the people who have epilepsy, and they have horrible side effects. A good example of sort of the ineffectiveness of anti-epileptic drugs and the side effects would be Mike Dancer and his story. So he was diagnosed with terminal epilepsy when I connected with him in 2008, I believe. And Mike had been on about a half dozen different anti-epileptic medications. And at the time, I was just starting to learn about the ketogenic diet, and he was going to go in to have brain surgery and part of his hippocampus removed. And if you guys know anything about neuroscience, that the hippocampus is a really important neuronal structure for learning and memory, and you don't want to go in there cutting things out, right? So, so Mike actually, kind of on a whim because he didn't have any other choice, I said, Mike, before you go and have surgery, try this ketogenic diet. I just discovered that the diet's original application was for seizures. So he tried it, and I was doing my postdoc at the time, very busy, but he was having a couple seizures per week. And when he started the ketogenic diet, I didn't talk to him for about 3 to 4 months, and when we connected again, he said, I haven't had a seizure. I started this diet, I started fasting, you know, and then transitioned to the diet, and it worked remarkably well for him. And it was, he went from being like literally a vegetable, he couldn't leave his house, to being very liberating. So Mike and I have actually traveled around the world talking about the ketogenic diet. So what's interesting is he is an adult that's using the ketogenic diet to manage his epilepsy. And previously, you know, in 2008 or 9, it was only used in kids. But since, you know, his story and more research that has been done at Johns Hopkins has validated the diet for adult epilepsy too. So Mike has found the ketogenic diet is something that's very palatable for him. He's very active in fitness. He's a power lifter, bodybuilder. It's very liberating for him. As an epilepsy patient, he's not able to drive a car, but we have a friend in Italy that has a plane, and Mike was able to actually pilot a plane, and that was like a huge experience for him and extremely liberating. So Mike and I have remained good friends, and he continues to use a modified Atkins approach to not only manage his seizures, but also as part of his fitness endeavors. So here's just a brief overview of the potential applications of nutritional ketosis. We all know about weight loss and type 2 diabetes, and Dr. Bullock will talk about that. Epilepsy, of course, autism, Angelman syndrome. Angelman syndrome is one of the more exciting projects that we have at University of South Florida. The Angelman syndrome is highly responsive to nutritional ketosis. So kids that have Angelman syndrome have seizures and very severe motor dysfunction. So Alzheimer's disease, Dr. Mary Newport was a speaker at our conference at University of South Florida a few weeks ago, a month ago, and there's publications on that. Parkinson's, Lou Gehrig's disease, ALS, traumatic brain injury, I think, is a really important topic that we need to do more research in. Cancer, you'll hear from Dr. Poff on that, and human performance, which Jake and Ryan are really spearheading the research in that. So we get to methods to induce, sustain, and support nutritional ketosis. And that's really what this product is all about. So I'm a big fan of the ketogenic diet, and I think that's kind of can be the foundation of nutritional ketosis. But even independent of your diet, so independent of carbohydrate consumption, you can take exogenous ketones and get the benefits of being in nutritional ketosis. So that really never happened before. And I'm really excited, and I kind of feel blessed to have stumbled upon this research and to be doing it, and to have other scientists, also being interested in also continuing this research as we get more collaborators involved with this. So the first ketone product that we sort of developed and tested was a ketone ester, and it's probably the worst tasting compound on the face of the earth. When you taste it, you feel like you've been poisoned. And, we've been working years on trying to flavor it, but it's really difficult to do that. You could potentially put it in the pills, but the volume would be high. So this is it is probably the most potent ketogenic compounds that we know of. And there's various ketone esters that we're testing. So ketone salts are naturally derived precursors that can be synthesized to form beta-hydroxybutyrate, which is a ketone, combined with a mineral, or what we call monovalent or divalent cation, sodium, potassium, magnesium, calcium. So beta-hydroxybutyrate can be combined with that to form a powder, a salt. And this can be combined with medium-chain triglyceride powder. And that's essentially a component that's in the Pruvit product that can quickly put you into ketosis and help you sustain it and support it if you're following the diet. So here's I don't have time to go into, probably running low on time now, I don't have time to go into all the research being done with exogenous ketones, but here's just a snapshot. I told you a little bit about oxygen toxicity seizures, neurodegenerative diseases ranging from Parkinson's to Alzheimer's to ALS. Angelman syndrome would fall into that category. Rare genetic diseases include glucose transporter type 1 deficiency syndrome. The syndrome involves the kids that have it have a deficiency in the glucose. Metastatic cancer, brain cancer, muscle wasting. Ketones have a protein periods of time and not waste away. If we didn't make ketones, we would break down and liberate all our gluconeogenic amino acids from skeletal muscle, and we quickly waste away. It probably wouldn't last more than a week or two fasting, but people have fasted for weeks to months. There's actually a report, I don't have it in this talk, but a guy that fasted for 380 days with no food. So it's a published report actually. He was like 500 pounds, but nonetheless, I mean, he was definitely benefiting from ketones. We're doing pharmacokinetic studies. There's really exciting data that I would love to talk about today, but we're putting together a manuscript now and putting together the data on anxiety and stress. So being in a state of nutritional ketosis really can reduce anxiety. anxiety levels in our rodent models pretty significantly. The results that we see show that in the rodent models, they go out and they have more exploratory behavior. And we think this has implications for PTSD, anxiety disorders. I'm really excited about that data, and we're putting together a manuscript now. Anesthesia resistance, hyperglycemia. One of the interesting effects of giving oral exogenous ketones is that it lowers blood glucose. How and why it's doing that is still something that we're investigating, but we think that it may be enhancing insulin sensitivity, and it may also decrease hepatic gluconeogenesis. So when we take in ketones, it may be telling the liver that it's in a fed state, and it lowers the output of gluconeogenesis in the liver, and that's a good thing if you have type 2 diabetes. Wound healing is an area that we're actively doing research on. We've shown that in aged model in ischemic wounds, it increases blood flow to the wound tissue. A pretty significant increase in blood flow. Age-related illnesses, we want to do a longevity study where we formulate a ketogenic diet and then formulate a diet with exogenous ketones and then the ketogenic diet with exogenous ketones together and just see how long animals live, like a normal healthy lifespan, and see if it gives an increase in longevity or delays the onset of age-related chronic diseases. Like certain animal models will get tumors as they age, and see if we can reduce that. Inflammation I talked about in performance. So I'm not going to get too much into the science here, but I'll just give you maybe an example of when we administered a ketone ester, within 30 minutes, and this happens with the ketone salt formula too, maybe not as potent at this time, but they're being formulated to do this, to increase the levels of ketones above what most people think of the therapeutic range of 2 millimolar. And this was a rat model, and this is the time on the y-axis showing that even at 4 hours, we can sustain the levels of acetoacetate and beta-hydroxybutyrate over time. And this was a whopping dose, and it was a single dose prior to stimulus that would cause CNS oxygen toxicity. So we think that these large doses would be necessary to mitigate oxygen toxicity seizures. And for a ketone ester, and maybe other ketones that are being developed, 1 gram per kilogram per day is essentially needed of the agents that are available to put you into nutritional ketosis. And for a 60 kilogram person, it would be 60 milliliters. And I'm 100 kilograms, so that would be about 100 milliliters is in this little vial here. And with that, within 30 minutes, you can get into starvation level ketosis. Some of the technologies that are being developed now to help monitor your status of nutritional ketosis are various urinalysis tests and also breath analyzers. And we're working with 2 or 3 different companies that are developing unique technologies that could maybe track ketones in real time. So think about putting a Band-Aid on your skin, and it has sensors in it, nanosensors that's detecting the presence of ketones in essentially real time, or every 1 to 5 minutes. And that can report to your smartphone. So you know that you can stay in a state of 1 or 2 millimolar of ketosis, and when you get low, you can drink the product and maintain whatever optimal state you feel good in. So these are things that are evolving. These are things that you'll see on the market in the next 2 to 3, maybe 5 years. So we did show that a ketone ester, getting back to oxygen toxicity, can delay the onset of oxygen toxicity by almost 600%. And that's most anti-epileptic drugs, even at high doses, fall into like this category. Don't even get halfway there. So here you have a substance that's a natural bioidentical metabolite of something that you can produce naturally, that you can give exogenously, that fuels your brain and helps preserve brain energy, metabolism, and brain homeostasis, even in the presence or the context of extreme oxidative stress, and that would be the hyperbaric oxygen, the high stimulus. So this has obviously a lot of different applications for the warfighter. we think that not only are we allowing neuroprotection, but we can enhance physical performance. I've given 3 or 4 talks at NASA, and they are very interested in the ketogenic diet because the energy density is much higher. So with a higher energy density, logistically, it's less space and it's more space that they can have on the shuttle and or on the mission. And the biological effects of ketones have been shown to mitigate some of the radiation damage that they think occurs in deep space flight, and also cognitive damage. So we know that neurological disorders are associated with impaired brain energy metabolism. And we've seen evidence shows that in people who have a normal brain, their PET imaging looks something like this. And with Alzheimer's disease, you see, depending on the level of Alzheimer's you have, significant reduction in brain energy metabolism. The reason for that is not completely understood. We think that there's an internalization of the glucose transporter on the membrane of neurons, that there's less activity of certain enzymes that are involved in glucose metabolism of the brain. What's important from the context of looking at ketones is that with brain ketone uptake, there's a linear positive relationship with plasma ketones being used for brain energy metabolism. So you have essentially, they readily transport across membranes to help preserve and maintain brain energy metabolism. And as we age, we get progressively decreased ability to use glucose as an energy source in the aging brain, and that same decrease does not occur with ketones. So as we age, we have a greater capacity to use ketones as an energy source in our brains, and that has significant implications for the aging population. Dr. Stephen Cunnane is really a leader in this research, and he's doing a combination in tandem. He's doing a glucose PET imaging and a ketone PET imaging, and comparing the results of that. And you'll see recently published several papers on this. So as it pertains to performance, there's research that was done at Oxford with a ketone ester that was developed at NIH, and that really inspired me to develop our ketone ester and ultimately the ketone salts that you guys are experiencing now or taking advantage of. And some of the early research, this goes back about 4 years ago, was I think the first experiment that we did in performance was with Dr. Peter Attia. And he's like, Dom, I want to try to reproduce some of the work that was done, at Oxford, and I have an idea. I'll get on a bike and we'll set the work output to 180 watts, and I'll do it before, administration of ketone salts and after. And we had a metabolic cart, and I had my ketone meter there. I had a table set up with everything that I needed, and I'm sticking Peter and drawing blood from him every 5 minutes, and he's kind of screaming because sometimes I'm sticking him too deep with the pin, and he was really a trooper. He stuck with it, but we did an interesting study, and Jake kind of did give you the punchline that at a given work output, there was enhanced oxygen utilization. So essentially what we saw, we need to reproduce this in our animal models, and we're doing some motor function testing. We have some exciting data with motor function testing in our rat models. It's too early to show you now, but we're working on a manuscript for that. Essentially you get greater energy efficiency when you're in a state of nutritional ketosis achieved with ketone salts. So implementation of nutritional ketosis, I could give hours of talks on this, on what I think is the ideal strategy. There's a lot of variations of the ketogenic diet out there, and I think Dr. Volek may talk about that. You have the classical ketogenic diet, the medium chain, the modified Atkins diet is really what athletes follow, and then ketone supplementation. And I think the combination of a low carb, more liberal approach to a ketogenic diet with ketone supplementation is the way to go. I'm a huge fan of the diet and just eating low carb in general, and not just taking the supplement and eating anything. So there's various ways to track your nutritional ketosis. We have blood levels, urine, and breath acetone. And all these technologies are evolving and I think will impact the people using this product. So here's some of my data with the formula, and this is me, I'm taking 2 doses. So I've taken the product for a long time, and I have a pretty high tolerance, a GI tolerance. And I'm in a state, this is time 0, and I generally stay, in the morning between 0.5 to 1 millimolar. And if I double dose on the product, because I'm a bigger guy, it shoots me up to a little bit above 2. And it starts to come down, almost to baseline after about 4 hours. So this is after 1 hour. I'm sitting at about 2.2, or otherwise I would still be below 1. And I think for optimal physical and cognitive performance, I think staying between 1 and 2, or maybe 1 and 3, would be ideal, depending on the application and depending on the person. So this is a really unique technology that can put us into a state of ketosis that I think is optimal. And more research needs to be done on showing what is the optimal. I get this question all the time, even from the Department of Defense. What's the optimal range to shoot for a guy that has traumatic brain injury, for a guy that has seizures, for a guy, a warfighter we want to enhance the performance. We still need to do that research. So Jeff, this is a figure from Dr. Volek's book, and I do think that staying in the 1 to 3 millimolar range with a combination of nutritional ketosis and exogenous ketones is really the way to go. So coming to the end now, I think the medical applications for nutritional ketosis are staggering. I think there's so many medical applications out there. We pulled this figure from our carcinogenesis manuscript and nutrition metabolism. If you get on the ketogenic diet and you can drop your blood glucose and elevate your ketones to achieve this metabolic zone, we think this is a powerful therapy for the metabolic management of aggressive cancer, and probably for seizures and other disorders too. So, and this level of this metabolic zone can be achieved far faster with the use of exogenous ketones. So I think I'm coming about to the end now. I'd just like to, so you guys are probably traveling a lot. I travel a lot for my job, and I get a lot of travel questions. And some ways that I make ketogenic traveling more simple and easy is to people say, I just can't follow the diet because I travel too much. And I don't believe that. So you can basically, in any restaurant, it could be keto friendly in just 3 steps. You order chicken, poultry, meat, or fish, main dish, and replace your starch, which could be rice, potato, pasta, or whatever, with a veggie, and just ask for extra fat too on the side. And pretty much every restaurant will do that. They'll give you olive oil, they'll give you a little dish of butter. Here I've got keto-friendly snack foods. Keto OS I think is awesome. It's lightweight. It fits into your travel bag very easy. Canned fish, beef jerky, nuts, macadamia nuts are something that I always travel with. Ketogenic bars. There's a Charlie bar coming out. So I'm working with a company that's developing the Charlie Foundation, a bar specifically for the Charlie Foundation. There's sugar-free chocolate out there. I love sardines. So a lot of people don't, but I think they're great travel foods. So just in summary now, I told you that, you can get into nutritional ketosis, get into ketosis with starvation, the ketogenic diet, and ketones are a very powerful super fuel. They're a very powerful endogenous metabolite. So when I got into this research, all we knew is that ketones were a form of energy. But since I started this research, now we've developed exogenous ketones can bypass and circumvent the need for the dietary restriction or the fasting to put ketones into the blood. And now we know that ketones are powerful neuroprotective agents, and they have powerful signaling effects on longevity, oxidative stress, inflammation, brain homeostasis, and brain neuropharmacology, and anaplerosis, which is a fancy term for generating more energy intermediates in the blood and the tissues. So, and there's all literature to support this, in the last 5 years. So with that, I would like to thank everybody for being here. I would like, most importantly, thank all the members of our lab listed here and shown here. They're really that's driving the research behind all this, and I'd like to really, again, thank Pruvit for putting this on, and Office of Navy Research. I'm here to answer any questions now. I don't know how much time I have, but now and for the rest of the day. Thank you.
Thank you, sir. I know there's a lot of questions out there, so let's let any questions.
Hi, my name is Tony. I'm from here, close to Tampa. I have a question about, you had mentioned that in some studies that you were looking at tumors in aging animals and things of this nature. Have there been any studies on actual brain tumors or any tumors in people?
Well, yeah, I think Angela will cover the topic. Maybe there's clinical trials, about 10 clinical trials going on right now. Most of the clinical trials involve using the ketogenic diet as a means to enhance or further augment the standard of care. So we know that being in a state of nutritional ketosis causes, by limiting glucose availability and achieving a state of ketosis, you sensitize the tumor to other modalities that could target it. But in the case of aggressive brain tumors or advanced metastatic cancer, the standard of care doesn't work. So they're sort of the types of cancer that we're focusing on, glioblastoma, for example, or advanced metastatic cancer, where as of right now, the standard of care just doesn't work. So we want to focus on the worst case scenarios, but we think the diet can be used, it is being used right now in clinical trials as a means to enhance. And Dr. Pop will cover some of that research.
Another question back here.
Hey, Dr. Dom, thanks a lot for coming out. And I think you heard a little bit about my story, but my name's Dom. Pretty awesome name. Two of the swellest guys in the room right here. So something that's near and dear to me is PTSD and traumatic brain injury, obviously from my experiences, where I was diagnosed with severe PTSD and a moderate traumatic brain injury. And as some people know, that traumatic brain injury shares the same symptoms as PTSD, the depression, anxiety, stress, the list goes on. But my question is can you elaborate a little bit why ketones and ketosis, or even supplementing with an exogenous ketone, can benefit some of these symptoms? That's one part of the question. The other one is the traumatic brain injury. With the cognitive function not being as good as what it used to be, with the trauma in the head, I mean, what's the reason behind that? Because we know with Alzheimer's, it's a glucose transportation, but what about with these traumatic events? And I know Brian was talking about wanting to do some studies and research behind that and why that affects. Can you elaborate a little bit on that?
Yeah, great question and highly relevant to our military personnel, or even people playing football that have had multiple concussions. And we know that even if you've had concussions, or maybe if you've had a subconcussive event, so multiple events, even if you don't have a concussion, that can lead to cognitive dysfunction. And there's studies showing that they are more sensitive. If you challenge people who had minor concussions with hypoxia, they do much worse than those who have. So getting back specifically to your question, once you've had traumatic brain injury repeatedly, remember that picture I showed you of Alzheimer's disease, the glucose PET scan, the normal? So TBI is like Alzheimer's disease in real time, right? So once you've had traumatic brain injury, you have the best outcome, the best predictor of how you will recover from traumatic brain injury is an FDG PET scan, right? So that's brain energy metabolism. So once you've had the injury, you have a lot of things going on there, and it depends on where the injury is and who the person is and that person's physiology and immune system and everything. But essentially what you have is impaired energy metabolism that could be mitigated, we think, with exogenous ketones. The faster you restore brain energy metabolism, the more likely you are to mitigate the downstream effects, which include post-traumatic stress disorder, results from probably the neuroinflammation, and we know ketones have an anti-inflammatory effect. And people who have severe traumatic brain injury, about up to 80% of those people with severe traumatic brain injury have seizures. So, and we know the diet is already the standard of care to control seizures, and it seems to work independent of the etiology of the seizure. So even if you're having seizures for some unknown reason, the diet tends to work. So it just makes sense to get someone who's had traumatic brain injury into a state of ketosis to quickly restore brain energy metabolism, lower inflammation, and prevent the potential of having seizures. And some of the anxiety data that we're showing, I think, has significant implications for PTSD. Some of the behavioral kind of things that are associated with PTSD. I don't know if that answered specifically your question.
I think what Brian's leading the way on some studies and research, I think maybe like with the behavioral things.
Yeah.
Because that's a huge thing, right?
Yeah.
We can really make some leeway on some of the issues. And those issues aren't just with PTSD, right? So that's the general population. But depression and anxiety, it's not just isolated to crazy people like me. So it's everybody. So I think it's really interesting how ketones can really help with that.
Yeah, some of these things are more challenging to study in an animal model. Jake is studying bodybuilding. It's kind of hard to study bodybuilding in mice, right? You can't put a little thing, a little mirror in the corner and stuff for the nice thing. But Jake is very innovative, and we'll find a way to do it. With depression and PTSD, it's a little more challenging. But I think we do have some pretty useful tools to screen out what formulas and what doses may be optimal, and we're excited to work with Brian on that and spearheading that research.
Thank you. Any other questions?
Hi, I'm actually going to read the question because I have someone. In fact, he had Lakeland, Florida. Cindy. Sorry. In fact, he has already had the surgery. He's like 24. He's already had the surgery that you were talking about that this gentleman had. They have for the seizures with epilepsy.
Oh, yeah, okay.
Yes,
okay.
he's had the surgery.
Yep.
So his mother is asking, are there any known contraindications with other anti-seizure medications?
Yeah,
when you're taking this?
Yeah, that's a great question. The community as a whole really feels that the anti-epileptic drugs work more effectively when you're in a state of nutritional ketosis. So I think, a lot like Mike actually went cold turkey. He basically didn't like the way he felt on the drugs, so he just kind of stopped and fasted and got into ketosis and then followed the diet, and it just worked for him. That's not the case in everybody, but it's the case in about 60 to 2/3 of the people who are completely resistant to drug therapy have a remarkable response to that. So I think if he's maintaining, anti-epileptic drugs, he may need to decrease the dose, and maybe he can titrate the dose down over time, potentially even wean himself off. But that's something that he'd have to work with his neurologist and epileptologist.
Okay, yeah, that's her second question. Is
Yeah.
what is a conversation that she can have with a doctor whose doctor says they don't want to introduce anything new until he bounces out on his medication?
Okay, so I would predict that he's probably having some form of side effects with the medication, and that needs to be adjusted. And typically what they do is add a higher dose or more medications. His doctor can simply look up, standard of care, and the ketogenic diet it's one of the few things that it's well accepted. Neurologists will accept it as, and my feeling is that it's grossly underutilized approach. So why not use something that's more of a natural approach and figure out, and if that doesn't work, add the drugs in later. But my recommendation would be to educate the neurologist or maybe find a better epileptologist. Dr. Pavel Klein, I work closely with him. He's in Washington, D.C. He's from Oxford University. He did the study with ketogenic diet in adults. And so if he connects with the Charlie Foundation or Johns Hopkins, those neurologists there know how to, many of them use drugs too, but many of them their idea is to get them off of the drugs. So they just need to work with an educated person who understands the diet and to wean the drugs off in a methodological way that works with the person. But if he's not having side effects on the drugs, there may not be reason to take them off. If they're a child, we know that these drugs have developmental effects that we'll see years later on. But if he's an adult, sometimes the drugs are good to include. Yes.
I don't exactly know how to ask, but my name's Kimberly. I'm from LaBelle, Florida. That's like this big. My son has paraventricular leukomalacia, cerebral palsy. Yeah. So my question is if I put him on a ketogenic diet, he actually attends Shriners there right beside UCF. That's where he's gone for all his surgeries and stuff. But will it increase the neuroreceptors that tell the muscles to move? I mean, could it possibly help that as well?
Yeah, there's not a whole lot of research on this. I've looked this up. We do need to. My speculation is that it would help. To what degree it would help, I can't even really speculate. But I think you would see benefits. I think nutrition really should be the foundation of medicine. I teach at a medical college, and the students want nutrition as part of the curriculum, right? Because we know it can impact so many things, and I think cerebral palsy is, definitely something that would impact, I think, your son. So my recommendation is to cautiously and look into this and look into ways to implement it in a clinical way, because you're dealing with a clinical scenario. It's not like weight loss or something like that. So we want to consult with someone who's savvy in implementing it. And Stacy Bassone is in the area, and she works for All Children's. It's part of Johns Hopkins, and you can look her up.
Hi, Dr. I'm Steve Welch from Chicago and here in Florida. I'm actually also a scuba diver and a certified rebreather diver, so I'm really curious. I know a lot of people in the diet industry, and with the advent of everybody using nitrox all the time for recreational dieting, do you have any human data and studies on recreational divers and possibly using ketones as a prophylactic therapy for preventing the seizures?
Mm-hmm. Yeah, that's a good question. We don't. All I do, I've just connected with the rebreather community, and there's a big rebreather community in Hawaii and a few other places, and I asked them to, tell me who's getting oxygen toxicity, and many of them will start getting hits like eye twitches, and then they know their bodies, and they'll, come up but it hasn't been studied in a rigorous manner, and obviously it's hard to study oxygen toxicity in humans because a lot of guys, the special ops guys, they won't report it even if they're hit, because they'll pull them from the mission if they do get oxygen. So that test that I showed you right there was a screening test, and if you get oxygen toxicity at that test, they'll pull you from. They'll kind of wean you out and say that you're going to be a risk factor to the mission. And so there's ways to screen these guys. It does need to be studied more thoroughly in humans. They need to report it, and they need to kind of just look at the research that's being done and develop protocols. It's all about safer diving, right? So that's why we have the dive tables, right? But the dive tables they're not 100%. So I think there's ways. We do know that nutritional ketosis has this profound anti-seizure effect, and people do die, underwater. So I think I connect with the dive community. I go to DEMA, I go to the other things, and I talk to all the rebreather kind of specialists out there.
We have time for one more question.
Hi, my name is Rebecca, and I don't want to say I'm from New York, but I came here from New York. Actually from San Diego, but I live in New York. Anyway, it doesn't matter. My daughter has retinitis pigmentosa, which there's no cure for and no treatment for, and she's 28 years old, so I've been dealing with this since she was a baby. FYI, the very first time she took Ketones, she goes, "Whoa, is it possible I can see better?" Okay, so, but the thing about the genetic disorders maybe having a change in them, my curiosity is, would it actually change like DNA? Is it possible we can change our DNA or unlock strands of DNA that are not being used, and perhaps that's why that's coming up? Rare genetic disorders, and hopefully, it is. I'm just wondering.
Yeah, that's a great question. We do know that beta-hydroxybutyrate has epigenetic effects, and these metabolites that are kind of elevated with fasting and the ketogenic diet have effects on gene transcription, translation, so they do have epigenetic effects. For that particular disorder, I don't know. There's numerous reports that when you're in a state of the eye is probably one of the most metabolically active organs of the body, right? So it's very sensitive to perturbations or metabolic dysregulation. So when someone gets in a state of ketosis, many of the reports are that I can see better, especially if they have some kind of underlying impairment. And we know that ketones can also prevent oxidative damage, oxidative stress. And there's disorders like macular degeneration, and a lot of eye disorders the eye is very sensitive to oxidative stress. You might be familiar with retinopathy of prematurity. If you put a baby into high oxygen, they can go blind, right? So, and I think ketones can mitigate that. So that's another study I want to do, actually, because it's still a danger. You put a baby in a high oxygen environment, and it's pretty risky thing. So for that specific disorder, like, I don't know personally, because I haven't studied that specifically, but from what I know as it relates to inflammation, the high metabolic rate of the eye, and oxidative stress, I think being in a state of ketosis would be helpful.
Thank you so much, sir. I appreciate everything.